All right. Applications of natural law.
Yay!
Last lesson of the term. Wow. Yes, I don't see you tomorrow. I see you on Wednesday. So I'll give you quite a bit of exercises to do. You got time to catch up on Wednesday. You got time to catch up on Friday. Plus, I'm pretty sure I'm going to give you a booklet of natural logs for revision. I'm going to give you a booklet on some past exam questions to do during the school holiday. All right? All right, now. So, by the end of this lesson, you should be able to model practical situation using the natural log, natural exponential and logarithmic functions and solve associated problem. All right? You should also be able to solve problems involving the rate of change of natural exponential and logarithmic function.
Yep.
All right. So, let's start off with looking at the first problem. Now, I'll give you some time to read the problems because I'm not going to read it out to you. Give you a couple of minutes to read that. Highlight information you think is important.
We use class webs. Yeah, you can just national. Mate, come on, you can do that. It's just 7.85973.
All right. So, if you look at a situation like this, it's the initial value problem where you're given an initial value and you're also given some information to determine unknown. All right, the coefficient of A times log of t plus 1 plus 20. Right, A is a constant. So now looking at part A, how many words did she already know in this language prior to taking the course? All right, 20. Why? Thank you. When t equals to 0, log 1 is 0, correct? So therefore, initial, that's 20.
Sure.
All right. Now, this is the most obvious. So you always look at something like this. You know that this is the y-intercept and that is the, this is 20. Now, think about log. If you have log problem, there's no y-intercept, correct? If it is just straight log without any transformation. So you need to have all the transformation to make sure that there's y-intercept. That is a initial problem, initial value, all right? So therefore, W is 20 words. Next one, if she acquired another 100 new words within 5 days, calculate the value of A. So you know that T is 5. You know that she acquired 100 new words. So therefore, W is 120. Yeah? Or straight away you can say that A log of t plus 1 equals 100. Either way. That's fine. Alright? So log of t plus 1 could be 100 or the whole thing is 120. So therefore you know A of log 6 is 100. So therefore A equals to 55.81. Now, in this situation here, keep it as 2 decimal places when you write. Okay. I'd like you to, when you are using your calculator, keep your decimal places. Keep your decimal places. All right? So from there, I can write the equation.
It's 100 divided by ln6. Yeah. Should be fair. Yeah.
Oh, I wrote it incorrectly. 100 divided. Yes, it is 100 divided by ln6. It's still 55.81. That's correct. Yeah. I did it correctly on the calculator, but I did not write it correctly. Sorry. It's 100 divided by ln6. I'll change that later before I put it. Okay, that's incorrect. It's reciprocal of that. All right. The next one. How long will it take to learn 220 new words? Again, use the same thing. Now, although I write the equation now as 55.81, but when you do your calculation with your class pad, use the whole, all the decimal places, please. All right. So therefore, it's 50 point t equals to 50 t equals to 50 0.51, that should be t. T equals to 50.51, so therefore about 51 days. I left my t out. About 51 days. Yeah. In this sort of situation, you can have 55.51 days, although there's hours in there, but strictly speaking, it's already 51st day that you, yep.
Wait, why did you do, oh yeah, okay. 220 new words, that makes sense, yeah.
Yes, 220 new words, therefore it's 240.
Yeah.
Okay. You already know 20. So this is a trick question. You already know the 20. So here's something like this, you got to add, add the 20, right? So it's 240. It's not 220. So it is a trick question because of that. All right, and then the next one, find an expression for her rate of learning. Rate of learning is just differentiate that term. The constant you don't have to worry is 54.81 divided by t plus 1. Log of t plus 1 is 1 over t plus 1. And then how long will it take? For her rate to learn all the vocabulary that this course has to offer. Because this occurs when the rate of learning drops to below 1 word a day. So if you drop to below 1 word a day, you really want that to be 1. 55.81 divided by t plus 1 equals to 1. And you can solve for t. So therefore, t equals to 54.81, about 55 days. I mean, really, in many situations, in this case, the 51.81, because you're talking about days. So even if you do 2 decimal places, it should be all right. It's just that if you have other situation, you have to use the whole lot. In this case, you are actually making sure that the days is just a whole day, not half the day. All right, I've got 6 examples today. So example 2 is just incremental change. All right, you should know your incremental change, which is, all right, before we actually do anything. All right, so you know that log 10 is approximately 2.303. And you need to use calculus techniques to determine an approximation for log of 9.99. So what I would do is I would actually write out y equals to log x. Know that there is actually a function. All right? Just the back of your mind, you know something like this. You should know the function y equals log x. Write it down, and you know that formula. Delta y is approximately the same as dy dx times delta x. And you can work out what delta x is. All right? So now you know x is actually 10. The reason why I write this function out is because then I know what x is. X is 10, so I know delta x is 0.01. All right? Makes life easier for yourself rather than just looking at this all the time. If you look at this all the time, just like, what is x? All right? So therefore, you know delta x is 0.01. And dy dx, you can work out dy dx is 1 on x. Now, the next thing you need to know is dy dx, you need to know at this point 10. So dy dx when x equals to 10 is 0.1, and therefore delta y is 0.1 times 0.01, which is 0.001. I will not be surprised if a question like this comes out in a calculator free, because it's not
easy numbers.
Yeah, you're expected to be able to do some maths, yeah?
Isn't the change in x negative? Yeah, negative 0.01, because you're going from 10 to 9.99.
That's right, but it doesn't matter because what I'm going to do is take away.
Okay,
It's okay. It's all right.
It's just passing.
Technically you're right, but it's fine.
Right, yeah.
Yeah. So so y equals to 2.302. See, I use take away. Yeah, I know it is negative, but
Yeah. That's weird.
I use absolute value in this case.
Yeah.
That's right. It's a small change, and then make sure that the answer is correct. That's
same
it.
thing.
Same thing. All right. All right. Oh, actually, delta x is correct because it's 10 going to 9.99. It's not 9.99 going to 10. So the small change is from 10 to 9.99.
Which is negative 0.
Yeah, which is positive. Yeah. Oh, yeah, it is negative. That's right. Yeah. So what was the question?
Oh, no, I literally was good luck on the exam. Say,
No, here. See, the change is that you got to reflect the correct change.
I did that in the end. But the first,
I don't think so.
All right.
You got the right answer. You got the right answer.
Yeah, I got the right answer.
Yeah.
All right. Let's go to the next one. Marginal rate of marginal rates of change.
I'm pretty sure you did it.
The cost of producing X units of commodity can be modeled by this equation, where X is greater than 0. So you need to calculate the average cost of production when producing 50 units, and then determine the marginal cost when 50 units are produced and interpret the significance of the result. Actually, now thinking about it, I may have to change the answer to negative first, and then the delta X -1.
No.
Estimate. In this case, it's estimating. I don't know. All right.
Marginal cost.
All right. What is marginal cost? First, let's not worry about marginal cost. Let's think about calculate the average cost. So the average cost of production when producing 50 units, you need to think about X is now 50. All right. So you need to use X as 50. Find the cost when it is 50 and then divide it by 50 so that you know the average cost. Average cost per items, per unit. So you can see that when X is 50, the cost will be 100 times log of 120, which means you've got approximately $478.75. Now, remember one thing. With dollar and cents, when you give your answer, 2 decimal places. All right, definitely have to be 2 decimal places. Use 50, X is 50. Now, you want the average cost, therefore you divide it by 50. So producing one item is $9.57. That's the average cost of production. So the marginal cost when 50 units are produced, and what you need to interpret the significance of the result. So you're thinking about the marginal cost is after 50 units, you need to produce an extra unit. All right? So you need to work out what, go back to what I've taught you in the first semester. Find the first derivative of the cost function. Once you can find the first derivative of cost function, which is 100 over x plus 10. So you need to work out what C at that rate is. When it is 50, is 167. So what does it mean? What does 167 mean? So 167 means the cost of producing the 51st unit is $1.67. So that's a marginal cost. The marginal cost of producing one extra unit. So go back and refer to your, recall the definition I've given you, marginal cost, in first semester.
That makes sense.
Right?
Why is it that? Why is it $1?
Huh?
So halfway there, 3 more examples to go.
It's imaginary land, man.
I would say that example 5 and 6 are probably the
Real
trickier one.
All
right?
Like
So example 4 is rectilinear motion.
it shouldn't change from 9 to 1.
Now, you need to recall rectilinear motion. It's displacement And the first derivative of displacement is the velocity, and then the second derivative of displacement, or the first derivative of velocity is acceleration. So you must be able to go from displacement to velocity to acceleration back and forth. So you know, just recall, when you're given x to velocity is first derivative. Alright, that's velocity. And then the second derivative or first derivative of velocity is acceleration. You must remember that. So you know how to go back as well. You know how to go forward and you know how to go back. So in this situation, you're given v. So you need to know to go back to displacement. Alright.
The left is negative. So you didn't say which is positive and which is negative though.
In this case, I would say that
Left is negative.
Initial position is 4 meters left of the origin. So left
It's
of
negative,
the origin,
yeah.
it should be negative left. Alright?
Shouldn't it be stated though in the question?
It should be, but
Okay. Yeah.
alright? So find an expression for x, the displacement of this particle, if the initial position is 4 meters left of the origin. So I'll assume that left is negative. Now, you know you should be able to integrate v to get your x. Alright, so you know what v is. So x is, you need to integrate 10 of 2t plus 1. So using the knowledge you have learned the last few lessons, so it's integrating 5 of 2 over 2t plus 1 dt, and therefore it's 5 log 2t plus 1 plus c. Alright, so now you need to work out c based on 4 meters left of the origin. Alright, when t equals to 0, x equals to minus 4. So therefore, you know c is minus 4. Again, this is something like the initial problem. Initial value problem. You know the initial value is 4 meters, but it's tied in with rectilinear motion, that's all. So from there, you can write x equals to 5 log of 2x, 2t plus 1 minus 4, and you should be able to find when t equals to 1.
What is it? Is it?
Alright.
Is it area is
when t equals to 1,
oh,
so it's 5 of log t, log 3
velocity.
minus 1, which is 1.4930. So it's about 1.49 meters to the right of the origin. Alright, now,
It's velocity.
Velocity. Yeah, that's cool.
so this is from the left, and then now this is 1.49 meters to the right. Alright,
1 meter. Wow.
so next. Now, determine the distance traveled by the particle during the 4 seconds.
The
Now,
integral.
why did I say that x is always increasing? The particle does not change direction. Why did I say that?
Because it cannot be negative.
Why did I say that?
Because
Can't
Why
be
do I
negative.
make that statement?
Can't be
t is
negative.
greater than 0, and then when you look on the graph, it's always positive.
Thank you. That's right. So t is always greater than 0. T cannot be 0, so it's always positive. The graph will be positive. It's increasing. Therefore, x is always increasing.
Yeah.
Make the statement. The statement that you make, just whoever is marking your paper, know that understand that the state x is always increasing. It's not going to change direction. So once you know that, you can do a distance travel in the the distance travel in the 4 seconds is between 3 and 4. So you can integrate v. between 3 and 4?
No, that's the third second.
Third and fourth seconds.
So wouldn't that be the third second?
Okay, let's
No,
let
no,
me
0
draw it
to
out.
1,
So,
1 to 2, 3,
you start from
5, 6. Yeah.
0 to 1,
Yeah.
1, 2,
True.
3 and 4. 3 and 4. So this is the first second, second second, third second, this is fourth second. So it's between 3 and 4. Yeah?
Yeah.
If you're unsure, do that, draw it up so that you know that what it is. Alright, it's between 3 and 4 because this is the first second, this is second second, this is third second, this is fourth second.
Why isn't it displacement?
Alright. So integrate between 3 and 4. Yeah, you got me there for a while. Why did I do 3 and 4? It's because I drew that. I realized that it's that. Thank you. Yeah, sometimes solving problem, because I'm used to it, I can straight away, I did not have to do that. But you're not sure, please do that. It will not give you like 12 or 13 seconds sort of thing, I don't think. But something like this, you should just draw it. And so therefore, work out to be approximately 1.26 meters. So really seriously with this sort of question, it's trying to trick you. The fourth second is not,
Yeah.
between the fifth and the, it's not after, not t equals to 4.
Got it.
You buddy.
All right, 2 more to go. The next one to me is the trickiest. All right, you've got a rectangle. It's in the first quadrant of the Cartesian plane, with one side of the positive y-axis, the other side on the positive x-axis. And the top right vertex on the curve, y equals to log of x divided by x squared, as shown on the diagram. Now, question like this, you may not be given the diagram. You may be asked to draw the diagram. Alright? I've drawn the diagram to make life a little bit easier for you. You need to use calculus technique to determine the dimension of the rectangle and the largest areas, and hence take this maximum area. Now,
How do you do this?
if you've got question like this, if you are asked in the in exam, if you're not, if it's not shown, hey, listen, you may have to sketch it on your class pad. At least sketch y equals ln x over x squared, so that you know that it's something like this, and you can draw that. So in this situation, the maximum could have occurred here, right? It could have occurred something like this. Agree?
Yeah.
Yeah? Yeah? So, it could be anything like this. It could even be that way. We don't know what it is. But we do know that if I draw it this way,
Not that hard, is it?
I know
Just
x and y.
Oh no, that's
So this distance is y, distance is x.
around
All right?
on X.
And then look at what this point is. What is that point? That point will be xy, and you know what y is.
Do you use a calculator?
So y is x, y is log of x divided by x squared, and x
How'd you do?
is x. So the distance here is x, and therefore the area is
Bro, it takes
log
1
x over
second,
x.
bro, trust me.
Correct?
Trust me.
I'll get a calculator.
So the area is therefore log x
It
over
takes
x.
longer to make a calculator.
No, it
Now-
doesn't, bro.
Nah, bro.
Well, you ready?
Yep.
Yeah,
Here,
I got it already.
realizing
All
that
we've done in 1 second, mate. Come on. Get him
Yeah,
a
but
level.
mine's like more.
Get him a level, mate.
this distance is
Come on.
x,
Mate, shit, mate. Look at
this
that.
distance is y. So the area is
mine's
x
like
times
more
y.
like, you know.
Oh, yeah? Oh,
X times y,
Okay, sure.
yeah.
x times log of x over x squared is therefore log of x over x. Correct?
Yep.
Yeah?
So, we do
So once
some
you've got
stationary
that-
point, isn't it?
You should be able to use quotient rule and your knowledge of log to actually differentiate that. So you need to know your calculus technique.
Wait, give me Euler number.
So by differentiating dA with respect to x, area with respect to x, dA dx, I use the quotient rule. The denominator is x squared.
Did you double this?
So therefore x
Double
times
diff, yeah.
1 over
Why
x
you just did this one?
minus log of x.
It takes
Because
too long.
Nah.
It takes way too. That takes way too long.
Wait, ready?
x times dy dx of log x is 1 over x.
Put one.
Don't put sign.
And log x times dy
Put
dx
1 and
of x
3.
is 1.
Bro.
If you got your calculator,
No,
bro.
bro, get out of here. That takes too long.
You get your calculator. It's
No, I'm telling you.
look 1, so positive.
X times 1 over x is 1 over is 1. 1 times 1 minus log x.
3. Bro, just plug and chug.
Mate.
All right, from there,
Oof. Negative.
dA dx equals to 0 when a equals to max.
Yeah, get out
when,
here,
when a is maximum.
Just
You
copy
know
it.
that x squared cannot be 0, correct?
Yeah.
X can never be 0. So therefore 1 minus log x equals to 0. Therefore log x equals to 1 and x equals to e. So at that point then, now this is now e. Alright? So if this is e, what would this be? Log of e is
Is it just 1?
1 over e. E squared.
Sorry.
Alright?
That wasn't tall.
So really, what you need to know is find x equals to e. Now,
So-
how do you know that it's
When you're solving for 0.
how do you know that it is maximum?
Double D.
If
Yes,
it's
second
not zero,
derative,
it's
dA,
So you can only do the
d2a
numerator
dx
zero.
squared. Work that out.
So 1 minus ln x. equals
Again,
0.
using your quotient rule.
Because then you have 0 over x squared.
And
0.
therefore, it is minus 3x plus log x over x to the power of 4. Now, substituting e in, you can see that is less than 0. This is always positive. This is less than e. This is 1. Minus
1 over
3e
e.
is greater than minus 3e. I didn't even bother working it out. I just said that's less than 0.
How'd you do that?
All right?
ln of e
I mean,
equals 1.
you could work it out if you want to, but you know that it would be less
ln
than
of e
0.
equals 1.
So therefore, the area is
See?
maximum
See,
when x equals to
Get
e.
used to not using a calculator.
So
mate.
substituting
Versus
into your
I
area,
would have put it in my
log
calculator.
e over
but
e.
alright.
Therefore, the maximum area is 1 over
See,
e.
this is exactly the point why I use the calculator. So if I don't use the calculator, I do dumb mistakes.
So can't you use first
Question like this, sorry?
use first derivative sign terms?
Yeah, you can use first derivative sign test, but in this sort of situation, yeah, I mean, 12 methods, yeah, expected to use second derivative.
Nah, scientist is elite.
Yeah, expected to use second derivative.
Scientist
It's not,
is
Easier to use first derivative.
yeah, it's up to you. I mean, look, there's nothing wrong with it. I don't think they can mark you wrong.
I mean, this has to be. Oh. Optimization questions are always calculator allowed. Usually.
Yeah, it should
most
be
of them
calculated
are.
around. Now the thing is, the most important thing is to recognize the fact that this point is at x and log x divided by x squared. That's the most important thing. Once you recognize that, you can actually work out what the area is, and it actually simplifies it. There's no x squared when you've got the area, right? So this is important for you to recognize. It's just where this point is at. So the last question is curve sketching.
This one's, I don't get this.
So this one, a curve is the equation y equals to log of 1 plus x squared. By first finding the coordinates and the nature of any stationary points
Put it in
and the
calc.
location of any point of inflection,
Bloody calc-free.
sketch this curve.
Yeah.
So
So you put in. You
this is a loaded
Put it in
question.
zero.
You need to find
You
a
put in
stationary
one.
point. You also
Put it
need to
two.
find a point of inflection. You need to use calculus
No. It's
or
not.
your second derivative test to show what the
can't
point
do
of
negative
inflection
stuff.
is, whether it's a
Mate.
concave up or concave down.
Negative
Alright?
1, plug and chug it
So-
into there, you'd see. ln 1 plus 1.
Let's start off with finding
Plug
dy
and chug, come on.
dx.
You're the plug and chug master.
I am plugging talking about. Yeah, you're right.
So the stationary point dy dx equals to 0.
See if it wasn't a square.
You know that 1 plus x squared cannot be 0, therefore 2x has
Because
to
you
be
know
0.
ln of 5.
2x has to be 0.
You
X
can't-
equals
well,
0.
I'm pretty sure it's can't free. If it isn't, then you can literally just.
Alright?
Yeah. Yeah. That's shit.
Now, if this were to be the last question and you run out of time, what I would do is at least get 1 point is by plotting this on your class pad and then sketch it.
Isn't there
Yeah.
another?
Alright? All the working out, you will then get a point, but you probably get 1 point for that.
Wait,
if
so
this
is
last
this
question.
class pad allowed?
If this is class pad allowed.
Oh, but
I don't know.
This is but then you can just chuck it into your
Yeah, but you need to show. You see, by first finding the coordinates, the nature, and understanding all the steps.
Yeah, okay.
Alright, you need to show. So like I say, if this is a class
did you
pad
graph it?
and then you run out of time,
No,
last
I don't know
question,
what it looks like.
at least sketch it
I just guessed.
Alright,
Alright, let me.
To
so
find the stationary
you
point.
got that. Then you can use d2y dx squared to see whether this is whatever you call it, maximum or minimum. Right. So therefore, with d2y dx squared, you would know that
Wrong.
this is greater
Yeah,
than 1.
I did a
It's actually,
dummy
yeah, that's what I
mistake.
said.
So it is a
a
greater than 0. Therefore,
Yeah,
it's a
yeah, mate,
minimum.
come on.
Because it's a positive,
Yeah,
therefore it's minimum. So you've got 1 point. Right. This bit you should be able to do.
X squared equals 1, x equals
Now,
plus 1 is
the
1.
next thing you need to think about
Plus
is the
one
point of
1, yeah.
inflection.
Yeah, that makes sense.
Point of inflection occurs when d2 y dx squared equals to 0. So now you know that 1 plus x squared to the power of 2 cannot be equal to 0. 2 minus 2x squared
Easy,
is
mate, come on.
0.
Come on, left one.
Alright? And therefore x equals
It doesn't go like
plus
this.
or minus 1. So you know that there's another point. X equals to plus or minus 1 is when there's a point of inflection.
Yeah.
Alright? Now, you need to find the concavity. So you need to do a concavity test. Alright?
Oh, yeah,
So
it's
point of
true.
inflection, possible point of inflection is that. Do your concavity test. Once you've done your concavity test, you would know
Dude, what? This is plug and chug. This is literally
Ah.
plug and chug.
that should be that, and that should be here. Okay, that should be that, that's that. So less than 0 is concave down, less than 0 is concave up. This is concave. This is concave up, concave down, concave down. Show the concavity. Once you've done that, you know that point of inflection is minus 1 log of 2 and 1 log of 2. Alright, you don't have to work out ln2. Natural log of 2, you don't have to work it out because you're sketching. You are only given the x and y axis. You are not asked to actually plot it. So you just take about 3 points and my really horrible way of sketching the graph.
So,
Something like this. Yeah. I'm not very good at sketching graph, alright, but I can get the message across, that's all.
Oh, okay.
That's all.
but
It's,
is it concave down?
I
Isn't it still going
don't
up?
think I even show the concavity very nicely for the
Doesn't it still technically go up?
for the point of inflection.
mean?
But that will do.
Like, doesn't it just infinitely go up?
No. It's going
Alright, like I
it's
say,
going down,
if
yeah.
this exam question
It's on the-
calculator
it
is
goes
allowed
back to 0.
and you're the last
It's true.
10
No,
seconds
it's not,
or
it's like on
1
down.
minute, just plot the graph. Alright? Make sure that you show the points,
What does
that's
it
all.
look like on class pad?
What? It just looks like that.
Alright, that's all the log. What I've done is, let me switch that off.